Hi everyone, welcome to Sravanthi Academy. Let's understand mathematics. Hi everyone. Next topic is sphere and hemisphere. Before going to this chapter, already I covered in this channel cylinder and cone also. Please go through it. If you have any doubt, please comment me. Now we have to see sphere. Sphere is like a ball. See, one circle we can take. Here only this is center and radius. Radius it will come. Surface area of the sphere. Surface area of sphere is equal to 4 pi r square. Here no total surface area and no curved surface area. Only one surface area it will come. 4 pi r square. Next, volume of the sphere. Volume of sphere is equal to 4 by 3 pi r cube. These are the sphere formulas. Next, spherical shell. Spherical shell means one solid in between two spheres. This is one sphere and one more sphere we have to draw here. This is center. It will form one solid inside of the spheres. This is solid. Here from center to first sphere radius capital R we have to take and second sphere radius small r. Here volume we have to take. Volume of spherical shell is equal to, what is the volume of the sphere formula? 4 by 3 pi r cube, because this sphere only radius r. Here how many radius we have? Two radius. One is capital R and one more is small r. We have to take difference r cube minus small r cube. This is the volume of spherical shell. Next, hemisphere. Hemisphere means this sphere we have to cut half. It will form two hemisphere like a bowl. Hemisphere shape like it will come. This is hemisphere. Here we have to observe. This is center. This is radius. Here you should observe this is center and this is radius. And from top part, this is also circle. From here to here, O to A. This is also radius. This is radius. Here, volume of hemisphere. How to write a volume of hemisphere? Half of the sphere. Half of volume of sphere is equal to half into, what is volume of sphere here? Volume of sphere 4 by 3 pi r cube. Here 2 1 just 2 2 just 2 by 3 pi r cube. This is the volume of the hemisphere. Next, volume of the surface area of the hemisphere. Surface area of hemisphere. Hemisphere is equal to, how to write? Whatever here surface area means full area we have to cover. This is half hemisphere, half of the surface area of the sphere. Surface area of sphere. Next, sphere. Next, what we have to add here? This top part also we have to add. What is the shape? Circle shape, pi r square. Half into, what is surface area of the sphere? 4 pi r square. 4 pi r square plus pi r square. Here 2 1 just 2 1 just 2 pi r square plus pi r square. Total 3 pi r square. These are the formulas. These formulas we can use and we can do next exercise. Next, exercise 20C. Here first main A problem. A solid metallic sphere of radius 16 centimeters. Here small r is equal to 16 centimeters and is melted to form a small identical spheres, each of diameter 4 centimeters. This larger sphere we have to melt and we will get a small identical spheres that diameter they have given d is equal to 4 centimeters. So radius how much it will come? Half of the diameter, 2 centimeters. Here R2 we have to take. The number of spheres we have to find out. N is equal to volume of larger sphere by volume of smaller sphere. What is volume of the sphere formula? 4 by 3 pi r cube. But we have difference purpose we wrote r1 r2. Here r1 cube because larger sphere. 4 by 3 pi r2 cube. 4 by 3 pi, 4 by 3 pi. Cancel. Here r1 value is 16. 3 times we have to write. By r2 value is 2. 2 into 2 into 2. 2 1 just 2 edges, 2 1 just 2 edges, 2 1 just 2 edges. 8 edges 64, 64 edges 512. So total number of spheres 512 it will come. Next B problem is a hemispherical bowl as external radius is equal to capital R and internal radius smaller. The outer surface area of the bowl. Here bowl already diagram they have given in textbook. This is capital R and this is small r. We have to take what they are asking, outer surface area of the bowl. Here outer surface, this we have to take as outer surface area is equal to, bowl means hemisphere. Outer surface area of the bowl means hemisphere. Here 3 pi r square minus capital R square. Capital R square minus this part we have to remove. This inside part we have to remove. So pi r square. This is the answer. Next problem number C. The ratio between the volumes of two spherical solids 27 is to 8. Volumes they have given. Volume of sphere 1 is equal to 27. Here ratio they have given volume of sphere 1 into volume of sphere 2 is equal to 27 is to 8. Next, the ratio between their curved surface areas. Curved surface area formula 4 pi r square. Here, volume of sphere 4 by 3 pi r1 cube. Here, two spheres we have. Here, 2 we have to take is to 4 by 3 pi r2 cube is equal to 27 is to 8. Ratio we have to remove. 4 by 3 r1 cube by 4 by 3 by r2 cube equal to 27 by 8. 4 by 3 pi, 4 by 3 pi cancel. Here r1 by r2 whole cube we can write. Here 27 is the perfect cube. 8 also perfect cube. How to write? 3 by 2 whole cube. Here 3 3 is 9, 9 3 is 27, 2 2 is 4, 4 2 is 8. Here cube cancel. R1 by R2 is equal to 3 by 2. Now what we have to find out? Curved surface area of the sphere. The ratio of curved surface areas. Here ratio between their curved surface areas. Curved surface area of the sphere. Total surface area, curved surface area both same. Sphere 1 by curved surface area of sphere 2 is equal to, what is the formula? Curved surface area of the sphere 4 pi r square. Here two spheres we have 4 pi r1 square, 4 pi r2 square. 4 pi cancel. Remaining r1 square by r2 square. Here r1 by r2 whole square. Already we have r1 by r2 value 3 by 2 we have to substitute here. 3 by 2 whole square. Here 3 square. 9 by here 4. 9 is to 4. Next to problem number D. A solid metallic sphere of radius 8 centimeters is melted and recast into 64 identical solid spheres. The diameter of each smaller sphere formed same like first problem, but here 64 identical solid sphere already they have given, n value they have given. Here we have to find out smallest sphere of the radius, means diameter we have to find out. First we have to find the radius. Here given conditions you should write. Here given larger sphere radius 8 centimeters. Here R1 we have to take, and number of identical solid spheres. N is equal to 64. Here small R2 value we have to find out. R2 we have to find out. How to find? What is the formula? N is equal to volume of larger sphere by volume of smaller sphere. Here n value is 64 equal to volume of the largest sphere, means sphere 4 by 3 pi R1 cube. 4 by 3 pi R2 cube. 4 by 3 4 by 3 pi cancel. Here 64 equal to R1 by R2 cube we have to write, because here R1 value already we know. Substitute in this equation. 64 equal to here 8 into 8 into 8 by R2 cube. Here R2 cube we have to shift left side. 64 into R2 cube equal to 8 8 64 into 1 more 8. Here 64 cancel. Remaining R2 cube equal to 8. Here 8 is the perfect cube. R2 cube equal to 2 cube we can write. Cube cancel. R2 is equal to 2 centimeters. But what we have to find out? Diameter we have to find out. Diameter is equal to 2R2. 2 into 2. 4 centimeters. This is the diameter of the smallest sphere. Next problem number E. In this problem, R1, R2, R3 are radii of 3 metallic spheres. If these spheres are melted to form a single solid sphere, the radius of the sphere formed. See here, 3 metal spheres we have to melt and we have to make one more sphere. Here, volume of larger sphere is equal to larger sphere. How it will form? 3 small spheres we have to melt and recast into this larger sphere. Here volume of sphere. Here sphere. Larger sphere. Here sphere 1 plus volume of sphere 2 plus volume of sphere 3. Here what is the volume of sphere? 4 by 3 pi r cube. So largest sphere value I took r cube. Here smallest spheres 4 by 3 pi r1, r2, r3 radius of the small spheres. Already they have given in textbook. R cube 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. RHS, what is the common? 4 by 3 pi is the common. Remaining R1 cube plus R2 cube plus R3 cube. Here left hand side 4 by 3 pi capital R cube. 4 by 3 pi, 4 by 3 pi cancel. Remaining R cube is equal to R1 cube, R2 cube, R3 cube. Cube we have to shift right side. Capital R is equal to cube root of R1 cube plus R2 cube plus R3 cube. This is the answer. Next problem number 2. In this problem, a volume of sphere is 38,808 centimeter cube. Find its diameter and surface area of the sphere. First, what they have given, that you should write. Volume of sphere. Volume of sphere is equal to, here, 38,808 centimeter cube. Here, diameter and surface area, both we have to find out. Volume of the sphere formula, 4 by 3 pi r cube is equal to 38808. Here, pi value is 22 by 7. 4 by 3 into 22 by 7 into r cube equal to 38808. These values we have to shift right side. R cube is equal to 38808 into, first 4 by 3 shifting right side means reciprocal, 3 by 4. Next 22 by 7 means 7 by 22. Here we have to do cancellation. Here 4 1 just 4 9 just 36, remaining 2, 7 just 28. Here 0, here 2 it will come. Next 2 11 just 2 4 just 8. 2 8 just 60, 2 5 just, and 2 1 just. Next, here we have to multiply. 11 1 just, 11 4 just 44, remaining 4, 11 4 just 44 and 1. Here total we have to multiply, and here 44 into 21, 9261 r cube. But we want r value. Here r cube, 9261 also perfect cube. 21 cube it will come. Cube cancel. R is equal to 21 centimeters. But diameter we want. Diameter is equal to double of radius. D is equal to 2R. 2 into 21. 42 centimeters. This is diameter. Next, surface area. Surface area of sphere. What is the formula? 4 pi r square. 4 into, here pi value is 22 by 7 into r value 21. Here how many times? 21 into 20 times, 2 times. 7 1 just, 7 3 just. Here we have to multiply. Here 4 2 ja 8, 8 into, here 3 1 just 3, 3 2 ja 6. 88 into 63. Here we have to multiply. 63, 88, 24, 48, 48 to 50. Here 504. 4455. 5544. Here area, centimeter square. This is diameter and this is surface area of the. Next, problem number 3. In this problem, a spherical ball of lead has been melted and made into identical small balls with radius is equal to half of the radius of the original one. First, original one how much? Smaller we have to take. Larger sphere radius is equal to smaller, and smaller sphere radius is equal to half of the original one. Now we have to find out how many such balls can be made. What is the formula? N is equal to, already I explained before MCQ time, N is equal to volume of larger sphere by volume of smaller sphere. What is volume of the sphere formula? 4 by 3 pi r cube. Here 4 by 3 pi. What is the r value here? Smaller sphere radius is r by 2. Here r by 2 whole cube. Here 4 by 3 pi, 4 by 3 pi cancel. Remaining r cube by 2 cube, 8. Here r cube by 8, we have to shift numerator. r cube into reciprocal 8 by r cube. R cube cancel. Total number of spheres is equal to. Next problem number 4. In this problem, how many balls, each of radius 1 centimeter, can be made by melting a bigger ball, diameter 8 centimeters? How many balls we can make, we can melt, and we have to make one bigger ball? Here smaller balls radius 1 centimeter and bigger ball diameter 8 centimeters they have given. Number of balls melted, that we have to find out. Here smaller ball radius smaller they have given. Here difference we have to take smaller. Here bigger ball diameter is equal to 8 centimeters. Radius half of the diameter, 4 centimeters. Number of balls we have to find out. Volume of bigger ball by volume of small ball. What is the volume of the ball? Ball means sphere. Volume of sphere 4 by 3 pi r1 cube by 4 by 3 pi r2 cube. Here r1 value, this is r1 bigger value, bigger one, and this is r2 we have to take. Here r1 is 4 centimeter, r2 how much they have given? 1 centimeter. Here 4 by 3, 4 by 3 pi cancel, remaining r1 cube by r2 cube. Here r1 value is 4, 4 into 4 into 4. Denominator R2 value is 1. 4 4 ja 16, 16 4 ja 64. So total number of balls 64. These 64 balls we have to melt and we have to make one big ball. Next problem number 5. In this problem, the volume of one sphere is 27 times that of another sphere. Volume of sphere 1 is equal to 27 times volume of another sphere. Sphere 2 we have to take. Sphere 2. Calculate ratio of their radius and surface areas. First, volume of the sphere formula 4 by 3 pi r cube. Here sphere 1, sphere 2. Two difference we need. R1 cube equal to 27 into. Here 4 by 3 pi r2 cube. Here 4 by 3 pi, 4 by 3 pi cancel. Remaining r1 cube equal to 27 into r2 cube. Here r2 cube we have to shift left side. r1 cube by r2 cube equal to 27. Here ratio we need. So divided by 1 we have to take. Here r1 by r2 whole cube equal to 27. How to write? Perfect cube. 3 by 1 whole cube. Cube cancel. Remaining r1 by r2 equal to 3 by 1. They are asking ratio. r1 is to r2 is equal to 3 is to 1. This is the first one. What is the second one? Surface areas. Surface area of second one. Surface area of sphere 1 by surface area of sphere 2 equal to, what is the surface area of the sphere? 4 pi r square. Here difference r1 square. 4 pi r2 square. 4 pi cancel. Remaining r1 square by r2 square. Here r1 by r2 whole square we can write. r1 by r2 value already we know. 3 by 1. 3 by 1 whole square. Here 9 by 1. So 9 is to 1. This is the surface area of the next problem number 6. In this problem, if number of square centimeters on the surface area of the sphere. Surface area of the sphere. Surface area of sphere is equal to 4 pi r square. Next, is equal to number of cubic centimeters of its volume. Volume of sphere. Volume of sphere. 4 by 3 by r cube. What is the diameter of the sphere? Sphere diameter we have to find out. First we have to find radius. Afterwards double of the radius means diameter. Here what is condition? What they have given condition? Surface area of the sphere is equal to volume of the sphere. Surface area of sphere equal to volume of sphere. Here 4 pi r square equal to 4 by 3 pi r cube. Here 4 pi cancel. Remaining r square is equal to 1 by 3 r cube. Here 2 times r square. Here 3 times r square. So remaining 1 time is there. 3 we have to shift left side. 3 is equal to r. Here r value is 3. Diameter how to find out? D is equal to 2r. 2 into 3. 6 centimeters. This is the diameter of the sphere. Next problem number 7. In this problem, a solid metal sphere is cut through its center into 2 equal parts. So what solid we are discussing here? One sphere we have to cut half. 2 hemispheres it will come. That hemisphere diameter they have given 3 1 by 2 centimeters. Here diameter of the hemisphere 3 1 by 2. Mixed fraction they have given. We have to change into improper fraction. 3 2 is 6. 6 plus 1 7 by 2 centimeters. Next, the diameter, find the total surface area of the each part. Means total surface area of the hemisphere. Correct to 2 decimal places. Here diameter they have given. Radius how to find out? Radius is equal to diameter by 2. 7 by 2 into 2. 7 by 4 centimeters. This is radius of the hemisphere. Total surface area of the hemisphere. Hemisphere. What is the formula? 3 pi r square. Introduction time already I explained. 3 into pi value is 22 by 7 into r value is 7 by 4. 7 by 4 into 7 by 4 because r square. Here 7 cancel. Here 2 just 2 11 just. Here 33 into 7 by 8. Here 7 3 just 21. 7 3 just 21. 23 by 8. Here long division method we have to use 231. Here 8 2 just 16. Here 13 minus 6 7 1. Here 8 8 just 64. Here 11 minus 4 7. Here 7 it will come. So 0.0. Here 8 8 just 64. Here 10 minus 4 6. Here 0 it will come. 7 just 56. 2 decimal points enough. 28.87. Here total surface area. Area means square we have to write. Centimeter square. Next problem number 8. In this problem, the internal and external diameters of a hemispherical vessel are 21 centimeter, 28 centimeter. First internal diameter they have given small r is equal to 21 centimeters and external diameter capital D we have to take. Here also diameter small d. Small r is equal to 21 by 2 centimeters. Here diameter d is equal to 28 centimeters and capital R is equal to 21 by 2, 14 centimeters. First problem, internal curved surface area. Internal curved surface area is equal to 2 pi internal small r square. Here 2 into pi value is 22 by 7 into r value 21 by 2 into 21 by 2. Cancellation. 7 1 just 7 3 just 2 1 just 2 cancel. 2 1 just 2 11 just. Here 11 into 21 into 3. Here you should multiply 33. Here 11 into 3. 33 into 21. 33. Here 66. 396. 693 centimeter square. Next, second one. External curved surface area. External curved surface area is equal to 2 pi capital R square. External 2 into 22 by 7 into capital R 14 into 14. Here 7 1 just 7 2 just. Remaining we have to multiply. Here 2 2 just 4. 4 2 just 88 into 14. 88 into 14. 4 8 just 32. 4 8 just 32. 35. Here 88. 2. Here 13. Here 9, 10, 12. 1232 centimeter square. Next. Third one, total surface area. Third one, total surface area is equal to, full formula we have to write 2 pi r square plus 2 pi capital R square plus pi of capital R square minus small r square. Here 2 pi r square value already we know 693 plus here 2 pi capital R square 1232 plus here pi value is 22 by 7 into capital R 14 square minus small r 21 by 2 whole square. Here 693 plus 1232 we have to add. Here 693, here 5, here 12, here 8, 9, here 1 plus 22 by 7 into 14 14 just. Here 14 14 just 16 4 5, here 14 196. 196 minus 21 21 just 441 by here 2 2 is 4. 1925 plus 22 by 7 into LCM we have to take 4. Here 4 6 is 24. Here 4 9 is 36. 36. Here 38. Here 4 1 just 4. 7 minus 441. Here 1925 plus this value we have to calculate 269.5 it will come. Here both we have to add 1925 269.5. Here 5 14. Here 8 9. Here 11. Here 2. 2194.5 centimeter square. This is the third problem. Here next one, fourth one, volume of the material of the vessel. Volume of material is equal to, what is the formula? 2 by 3 pi capital R cube minus small r cube. Here 12 by 3 into pi value 22 by 7 into capital R value is 14 whole cube minus small r 21 by 2 whole cube. Already we did same problem before. Here 44 by 21. Simplification we have to do. Here 14 into 14 into 14. 2744 minus here 21 by 2. 21 by 2 whole cube Full we have to calculate 57.625. We have to subtract 44 by 21. Here subtraction we have to do 1157.625. Here 2744. 0, 0, 0. Here 5. Here 9 minus 2. 7. Here 9 minus 6. 3 point. Here 3. 13 minus 13 minus 7. 6. Here 13 minus 5. 8. Here 6 minus 1. 5. Here 1. Here into 1586.375. Here we have to calculate. We will get 3 bull 3323.83. Here centimeter cube. This is the volume of the material. Next problem number 9. In this problem, a solid sphere and solid hemisphere have the same total surface areas. First formulas you should write. Surface area of sphere is equal to 4 pi r1 square. Next, surface area of hemisphere. Hemisphere 3 pi r2 square. Difference purpose r1, r2 I wrote. Next, here what they gave condition. Here surface area of the sphere is equal to surface area of the hemisphere. Both equal they have given. Here surface area of sphere is equal to surface area of hemisphere. Here 4 pi r1 square is equal to here 3 pi r2 square. Here pi cancel. Here 3 we have to shift left side. R2 square is equal to how to write? 4 r1 square by 3. Here square we have to shift right side. R2 square is R2 is equal to root of 4 r1 square by 3. Here 2 r1 by root 3 it will come. This is R2 value. We can use afterwards. Equation 1. Next, what condition they have given? Find the ratio between their volumes. This sphere and hemisphere volumes ratio we have to find out. First formula we should write. Volume of sphere 4 by 3 pi r1 cube. R1 value as it is you should keep. Next, volume of hemisphere. 2 by 3 pi r2 cube. R2 value how much? 2 r1 by root 3 we have to substitute here. 2 by 3 into pi. R2 value is 2 r1 by root 3 whole cube. This we have to substitute. Now ratio find out. Volume of sphere by volume of hemisphere equal to 4 by 3 pi r1 cube by here 2 by 3 pi here 2 cube 8 here r1 cube by root 3 whole cube. Root 3 whole cube. Here root 3 whole square into root 3 we can write. Square root cancel. 3 root 3. So instead of root 3 whole cube place we can write 3 root 3. 3 root 3. Here r1 cube cancel. Pi cancel. Remaining you should write. Here 4 by 3. Here 4 by 3 divided by here 8 2 just 16 by here 3 3 is 9 root 3. Here denominator value we have to take numerator. 4 by 3 into 9 root 3 by 16. 4 1 just 4 4 just 3 1 just 3 3 just 3 root 3 by 4. This is the value. Next problem number 10. In this problem, a metallic sphere of radius 6 centimeter, 8 centimeter and 10 centimeters. So 3 radius they have given. 3 spheres we have to melt and recast into a single solid sphere. Taking pi value is 3.1. Find the surface area of the solid sphere. Here what they have given, 3 spheres radius they have given. R1 is equal to 6, R2 is equal to 8, R3 is equal to 10 centimeters. These 3 spheres we have to melt and we have to make one more solid sphere. Here centimeters, centimeters and centimeters. Here volume of bigger sphere it will come. Bigger sphere equal to, how to write? These 3 spheres we have to add means this volume it will come. Volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3. Here 4 by 3 by bigger sphere radius capital R we have to take. Here volume of the sphere 4 by 3 by R1 cube plus 4 by 3 R2 cube plus 4 by 3 by R3 cube. What is the common RHS? 4 by 3 pi is the common. Remaining R1 square plus R2 square plus R3 square. Here we have to substitute R1, R2, R3 value. 4 by 3 into pi. Here R1 6 square plus R2 8 square plus R3 10 square. Here RHS 4 by 3 pi capital R cube. 4 by 3 pi, 4 by 3 pi cancel. Remaining R cube equal to, here 6 into R cube, sorry. Here R cube, cube, 6 cube. 6 into 6 into 6, 216 plus, here 8 into 8 into 8, 512 plus 10 into 10 into 10, 1000 it will come. Here we have to add 216, 512, 1000. Here 8271, 1728. R cube equal to 12 cube. 12 cube value is 1728 it will come. 3 3 cancel. R is equal to 12 centimeter. This is the radius of the bigger sphere. Next what we have to find out here? Find the surface area of the solid sphere. Surface area of the sphere is equal to 4 pi capital R we have to take. Here 4 into pi value how much they have given in textbook, 3.1 into R value is 12. 12 into, sorry, here square. Here 12 into 12. Total we have to multiply. Here point we have to remove, 4 into 31 by 10 into 12 12 is 144. Numerator we have to multiply. We will get 17856 by 10. Here denominator 0. One point we have to put one decimal point before 6. Here area centimeter square it will come.